Well, thank you very much for having me. Really excited to talk today about my PhD project at Strathclyde. And we're going to talk about thermal energy storage at Comrie Colliery today. So, what's going on here? Right then. So we've covered this a little bit already this morning. What is thermal energy storage, and why do we want to actually store it in mine shafts? Thermal energy storage is basically you taking excess thermal energy and putting that into a storage medium to then be taken out at a later date when the energy demand is higher and the supply maybe isn't there. And this project is investigating thermal energy storage in mine water within mine shafts. Mine systems flood after they get abandoned, being due to being lower than the water table. And this mine water, the water within that mine, is a really good storage medium for heat. So we've got a couple of questions going into this. Sort of an overarching question for the project is, how do we actually safely access mine shafts for heat resources? And then a question more specific to this project is, how can we address really important data gaps in the context of assessing for heat resources in mines? So Comrie itself is a former colliery, abandoned in 1986. And recently, Comrie Development Company there are considering, well, they're going to be putting about 300 holiday homes on site, as well as some other developments, and they want to provide as much electricity and heat to that site with low carbon resources. So they want to utilize the mine underneath the site there, and we're looking at shaft number 1 on site because we have it on good authority that that shaft has not been backfilled with mine waste material. However, the site, like Charlotte suggested, this site has no surface sort of reference points on it, so it's a bit of we sort of have to do quite a lot of study around that, and we started that with a desk study. So when we're talking about thermal energy storage, we need a couple of ideals that we'd like from our storage site. We want a large volume, which we have in the mine shaft, because it's we've got the specifications of that is over 12,000 meters cubed of available space in there. Already filled with a high energy density medium. Water has got quite a high specific heat capacity, and there's going to be a considerable amount of water in that shaft. We can't say for certain the level of it, but it is going to be in there. It would be well insulated. The mine shaft in this case is concrete lined, and throughout many of the collieries in the UK that were built in the 20th century, quite a lot of them will either be brick lined or concrete lined being the preferable there. They're often very well documented, these mine systems, thanks to the Coal Authority and all their data collection they have. And also we want it to be located near end users to limit thermal losses. Obviously, in this case, the site is being built on top of the colliery, and the shaft will be very close to the developments. So to actually investigate the water within these shafts to then determine whether the mine water in there would withstand being heated to any significant degree, we need to actually access the shafts via a borehole, so we can test the water within there. But with the available data, we can't do this because we don't know exactly where the shafts are. We've got coordinates for them, but we don't actually know where they are specifically. and also there's no available abandonment plans. We've searched high and low, but we can't find them anywhere. So to answer these questions, how do we fill these important knowledge gaps? We need to get our hands dirty, get out to the field. So we went to the coordinate sites. The person in the high vis there is my supervisor, Neil. And then this man here is Alan Kenny. Now, Alan is he works for Comrie Development Company, but he's also a mining engineer on this site when it was operational as a colliery. So a lot of expertise there from Alan. So we started to dig a trial pit with the excavators, and eventually we uncovered this concrete pad here. Now, we didn't know exactly what this was when we first uncovered it, so we thought we need to investigate this further, and we did that by employing geophysical surveys and geophysical techniques. Now, this is Philippe, geophysicist from Strathclyde. We used GPR and we also used EM to investigate what might be underneath the concrete pad there. And unfortunately, both GPR and the EM surveys came back pretty inconclusive. This is probably due to the fact that the made ground around, underneath the concrete there and around it, you can see there's lots and lots of metal, like these pipe works. There's bits of scrap metal in there. It maybe isn't the best technique to use on this specific site, but might be able to add insights to a site that maybe has less waste material on top of it to find what's underground there. And what we were looking for was any sign of a cap or a plug over a mine shaft, because we thought that this concrete might actually be covering that cap or plug at the surface. So we needed to go a little bit deeper. So what we did was just set up an ERT survey, 47 meters long, with nodes at every meter. And it was a very, very cold day on this day. And we managed to get a nice ERT section through there. And we came up with this section here. Now, I've highlighted where the concrete pad actually is, which we found in the hole. And then we've got these two really large anomalies that I've put in boxes numbered 1 and 2. Number 1 is quite close to the surface, and sort of area of really low resistivity, areas where electricity is the current isn't really being able to translate through the ground there. It's got 1 up here, and then 2 a really big anomaly down at about 8.5 meters. ERT going down to 8.62 meters, the GPR and EM methods going to about 5 and 3 respectively. So what we wanted to do was investigate these anomalies further. And so before I go on to the next slides, we've got an old picture of Comrie when it was operational. This is the winding gear over number 1 shaft, and number 1 shaft will be in here somewhere. And then there's the concrete pad that we've uncovered, and then there's the old wash house where all the coal got sent to be sorted out. Now this is important because if we've found this concrete pad with our excavation, we know that the shaft there will be to the south of where this concrete pad is. So we're in the right zone with our digging, but we've still got a little bit to go. So then we dug south, and that's actually where the anomaly, number 1 anomaly, was for the RT. And we've uncovered concrete infrastructure. This here, we think, is one of the foundations for the headgear that we saw in the previous photo, and that would correlate to this concrete pillar there. And in addition, we've also found potentially the foundation for the wash house. So we reckon that the shaft itself will be here, as it translates across to about there from the schematic there. and that's the concrete pad that we're standing on right now. So we've managed to confine the shaft to this sort of area potentially, which is quite exciting. And then we've started as well to collect water data from the site. We're looking at C1, C3, and C4 and C7 for the next slide. C7 is the excavation that I've just shown you, and filled with water. We don't know where the water is actually coming from, but we did test it, and we're going to investigate that further. But that's an important thing to note as well, is that when we dug south, we hit quite a lot of this water that was quite interesting, chemically and physically. The water in the excavation there, C7, these are the field measurements for it. A temperature of 16.2 degrees, and a pH, a circumneutral pH of 7.3, and a negative 45 ORP, which potentially suggests that actually the water hasn't come into much contact with the air. So we don't really know where this water's coming from, but it could be coming from the mine shaft itself, potentially. So yeah, that was pretty much it from me. Thank you very much for listening. Hope you enjoyed it.